And welcome to the video on k-means clustering algorithm. This is the first unsupervised machine learning algorithm that we are going to cover in our course. So let us start. K-means clustering is an unsupervised learning algorithm which groups the unlabeled data into different clusters. Here, K defines the number of predefined clusters that need to be created in the process. As if k is equals to 2, there will be 2 clusters created, and if k equals to 3, there will be 3 clusters created, and so on. So it is an iterative algorithm that divides the unlabeled dataset into k different clusters in such a way that each dataset belongs only to one group that has the similar properties. Now it allows us to cluster the data into different groups and a convenient way to discover the categories of groups in the unlabeled dataset on its own without any need of training. As this is an unsupervised learning algorithm, so we don't have that training, testing, and all that part that we used to do in algorithms like random forest, decision tree, logistic regression, etc. etc. So it is a centroid based algorithm where each cluster is associated with a centroid. The main aim of this algorithm is to minimize the sum of distances between the data point and their corresponding clusters. So this is the graphical representation of k-means algorithm. So before applying the k-means clustering, this is a simple scatter plot of the data that we had. Now once we performed k-means clustering on this data, now we have something like this. So this one is considered as one single blue cluster. This green one is the second cluster on the top, and third cluster is the black dots that we have on the right hand side. So let us understand how does the k-means algorithm work. So the working of the k-means algorithm is explained in the below steps. So the step 1 says that we have to select the number k to decide the number of clusters. Now we will see the elbow method that is used to determine the number of clusters that we are going to make from the dataset. So the first step is to decide the number of clusters that we want to create. For that, I'll teach you about an elbow method later in this video. Now second, select random k points or centroids. It can be other from the input dataset. Now step 3 says that assign each data point to their closest centroid, which will perform the predefined k clusters. Now step 4, calculate the variance and place a new centroid of each cluster. Repeat the 3 steps, which means assign each data point to a new closest centroid of each cluster. If any reassignment occurs, then go to step 4 or finish it. Now the model is ready. So let us understand this. Suppose we have two variables m1 and m2. The xy axis scatter plot of these two variables is given below. So this is a scatter plot. Now let's take number k of clusters. We want to make two clusters out of the scatter plot and the dataset and to put them into different clusters. It means here we will try to group these datasets into two different clusters. Now we need to choose some random k points or centroid to form the cluster. So these 2 points can either be the points from the dataset or any other point. It doesn't matter. So here we are selecting the below 2 points as the k points. So we are selecting these 2 points as the initial cluster centroids, which are not the part of data set. So these 2 points are not the part of data set. We are selecting them as the initial cluster centroid. Now we will assign each data point of the scatter plot to its closest k point or centroid. We will compute it by applying some mathematics that we have studied to calculate the distance between 2 points. So we'll draw a median between both the centroids. So from the above image, it is clear that the points on the left side of the line lie near to k1 or the blue cluster center, and points to the right side of the line are close to the yellow centroid. So let's color them as blue and yellow for clear visualization. So after this is the initial, this is the initial two clusters that we have made after selecting a random centroid. Now as we need to find the closest cluster, we will repeat the process by choosing a new centroid. To choose new centroids, we'll simply compute the center of gravity for these centroids and we'll find new centroids as below. Now we will reassign each data point to the new centroid. For this we will repeat the same process of finding the median line the median line will look like the given image. So this is after changing the center of gravity for the clusters. Now we can see one yellow point is on the left side of the line and two blue points are on the right side of the line. So now these three points will be reassigned to the new centroids. Finally, it will look something like this. So all the blue points are on the upper side of the line, and the yellow points are below the line. So as reassignment has taken place, we will again go back to the step 4, which is finding new centroids or K points. So we'll repeat the process by finding the center of gravity of centroids. So the new centroids will be shown in the below image. Now we got new centroids. So again we'll draw the median line and reassign the data points. So the image will look something like this. Finally, we can see in the above image there are no dissimilar data points on either side of the line, which means our model is formed. In this image, now our model is ready and we can remove the assumed centroids, and two final clusters will be shown as you can see in this image. So this is how k-means clustering works. I hope you are very clear with the basic working of k-means. Now let's move to the practical section and try to implement it in the Jupyter notebook. So let us start with the practical implementation of k-means algorithm. In this cell I have imported all the required libraries. So we'll be using NumPy, Matplotlib and Pandas. So importing the dataset inside a Pandas data frame. So mol customers.csv by using pd.ratecsv. Have a look at this dataset. We are having customer ID, gender of the customer, age of the customer, annual income in $1,000 and spending score in 1 to 100. So based on all the features, all the different features that we have for the customers in our dataset, we have to cluster them. So a practical use case of this k-means or customer clustering approach can be the retail store or the online store can throw up different offers to the different customers falling in different clusters. Let's say a customer with the high annual income and high spending score will receive the offers for slightly expensive things, and in case if a customer is not that old or has a low income or does not have a very high spending score, so the store can pitch or sell or advertise cheap products to that customer. So based on the cluster of that customer, the store can advertise different products. So this can be used for effective marketing. So this is the dataset that we're going to use. Now these are all the features that we are going to take into account, and here in unsupervised learning techniques we don't have to use the x and y or the dependent or independent features. We just simply have to choose the features from the dataset. So if I add one more cell and if I write x over here, so these are the two features that we are going to use. So annual income and spending score. Now moving on, as I told you, we are going to use something called an elbow method to find the optimum number of clusters. So the code for elbow method is given over here, and the full form for WCSS is within cluster sum of squares. We are not going to go in a lot of mathematical detail about this elbow method, but simply by using the elbow method you can plot this elbow shaped graph, and the optimum number of clusters will be the point on the graph where the graph starts to flatten. So here in our case, this can be the optimal cluster point or the elbow point of the graph. So this is for 2, 3, 4 and 5. So this is almost 5. So we can get a decent idea about the number of clusters. So based on this elbow graph, we can directly say that the number of clusters that we are going to make from the given dataset will be 5. You can try the code for elbow method on different datasets and try to figure out the optimum number of clusters as a practice. So here I am calling the k-means model, and the number of clusters that I am going to use is 5. And then k-means dot fit predict. This is the method fit predict that we are going to use when you're working with unsupervised learning algorithm. Now here, as we are not predicting a certain value, so there's no point of accuracy or any other metric. So we'll simply visualize all the clusters that we have made. The code for visualizing the clusters is given over here. clusters of the customer, annual income is on the x-axis and spending score is on the y-axis. And based on all the both the features, we have created 5 different clusters: light blue, dark blue, pink, red, and green. So these are the 5 different clusters that we have created, and the yellow ones, the yellow dots are for the cluster centroids. So this was the working of k-means clustering algorithm. I hope you are very clear with this.